Okay. So again, good morning, everybody. In this presentation, I'm going to speak a bit more about my company, that is Glayx. This is part of Glayx Group, not Glayx Technology. And now I'll explain why. So the company's Glayx was founded in 2009, and the founders came out from an excellent academic curricula, and they decided to address a particular focus on renewable energy efficient solutions. In particular, after 4-5 years development of the business, we are currently operating into different segments that I showed you. The first one is the EPC. That is a large, I would say, large term to define everything. In this case, we consider a company an EPC since when we find a possible project, we are able to deliver turnkey solution, and we are able to follow the customer in each step of the I hope successful history of the project. And we can follow even him after the end of the project and the constructions. In particular, we have developed a lot of renewable power plants, both photovoltaics, biomass, and biogas. At least more than 20 megawatts at the end of 2014. And we did the same EPC approach for many project intervention in the fields of energy efficiency in the industries. Another part that is coming more and more important this moment is the project financing of our design, in the sense that, as you will see later, we did an improvement in our business model to include the possibility of financing the whole concept. Okay, the second business segment is a particular one for us. So we are a small, really small, very small energy utility, in the sense that since foundation, the company has decided to dedicate a fixed amount, percentage of the earnings, investing directly in the ownership of power plants. That has, everyone has a particular environment, and we would like to call it as a sustainable project in renewable energy. You can find here two small examples. One is a biomass plant in southern Italy of 1200 kilowatts. And in that plant, we are going to integrate our concentrated solar power system very soon. Maybe will be ready in the first quarter of 2016. Another example is 1 megawatt photovoltaic plants, again in the southern Italy. And these are, for us, these are like the demonstration that we believe in what we do. So we trust the technology, we trust the renewables, and we operate just in the free market of energy in Italy. So we deliver the energy in the network, and we get paid at the price I show you this morning in the other presentation, so with the oscillation and all the matters about that. This is a particular, sorry for the title. This is as I was speaking a few minutes ago. In the last year, we decided to add, I would like to call it as a service to our customer, that is the energy service company model. Maybe many of you know what I'm speaking about, so sorry for repetition. I did show here only one type of possible energy service company model, that is the share saving business model, that is represented in this scheme. That means that the company, that is always Glayx, is in charge of execution and financing a project. The project comes out from our energetic audit, from a detailed design of an opportunity, and allows for of course, for the customer to maintain his capital availability for his business, more than for something that is out of his business. In this period, many companies are facing, long crisis, and even if are aware of the possibility of have earnings from efficiency, they prefer to invest the money in something related to the product, and this, I think, is even a good environment. So we have been we were particularly sure of the fact that this model can be appreciated, and it has been in Italy for this year. Of course, creates a new task for us, that is the financing of all the project. The scheme is quite easy in the sense that we have an energy service contract or sometimes an operative rental. Is something really similar. But the concept is that for a period lasting from 5 to 15 years, depends on the type of intervention, the type of repayment that it can give to the company. In this case, Glayx. We have an X% savings that every year come again to be a repayment for the Glayx investment, and again an Y% of the savings that goes directly to the customer. It means that the customer immediately after the intervention start to have a small amount of earnings, but anyway it earns something. And in the meanwhile, of course, we are facing many difficulties to enlarge the model to companies that are facing economical crisis, and it's easy for you to understand why, because when Glayx moved to the financial markets, we are asked not about our company that maybe have even good numbers, but about the numbers of the customer, because we get repaid from him, not from our work in this case. Okay, now I come with more focus on Glayx Technology, that is the division and the spin-off of Glayx. That was founded in 2012 to highlight the focus of the company on research and development on new solutions. I did a very small summary of the ongoing activities after, I say, 3 years intense activity, because I'm in charge of Glayx Technology since the foundation. So we have been working a lot on our first project that is concentrated solar, and as you will, maybe you know, we will see later on, we now terminate the development process and we are ready to deliver it as a product called Thermex. The second project is going on is the methanation process, so the so-said inside our company Gas for All. So the project has been starting in 2014, and the project is addressed to the construction of a system that allows the conversion of electrical energy into the reverse methanation production. This is something that our National Energy Agency have been working a lot in Italy, obtaining even promising results. And in collaboration with them, we are trying to recover all this and find an applicable solution. I just want to make more words on this. The idea of methanation arises from a problem that I showed to you this morning, that, for instance, in our region in Tuscany, there are many wind plants that have a great issue of being detached by network for many hours during the year. So even if they have capability of 2,500 hours a year, there is a possibility to lose up to 1,000 hours. And this happens because of the tremendous matters we are facing in Italy on infrastructures due to renewables and due to the varying load of renewables, especially wind. And this particular plant, of course, as you may imagine, are placed, all wind plants in Italy are placed very far away from normal high voltage distribution, and this, of course, enlarge the issue and the problem. The methanation can be a solution in that, because you have a sort of, you have electrical energy generated by the wind power. Okay, it can be applied the same also to other renewables. whose energy value is zero for definition, because that would be a wasted energy. So if you close the plant because you cannot produce, it means that your price is zero, okay? So if you have zero energy, why you need to waste? You can recover in a system that use the good methane network in Italy, because in Italy we have maybe one of the largest in Europe, and each place has in few kilometers the possibility to enter the natural gas network. The last one is a project strictly connected to the first one, again with our ENEA support regarding the thermal storage. So we are trying to do a system, to involve a system with synthetic zeolite that has a particular characteristic of keeping heat without having any temperature difference. That means that we have the possibility to store energy at low temperature, and we can release this energy even in a future moment, of course, without any loss, and even in a different place. Okay, so it's only a problem for transportation, for movement of material, but the concept is I have a sort of materials that captured my thermal energy that is at ambient temperature, so I'm not losing anything on an energy balance view, and is movable, I would say. So we can move to different user, of course, in a limited area. Okay, now I come to the project of Thermex. Thermex is just the object you are looking there on the left. It has been developed with the University of Pisa, that is part of the famous Pisa University system that Lisa was speaking before. Here you can find major technical and geometrical data of the system. I don't want to go into this detail because I think it's not so interesting for any of you. Of course, if anyone has more question and curiosity, I'm available. I like to underline the last two numbers that has been certified according to the UNI, that is EN 12975, and from, as I was saying, the Energy National Agency for Energy in Italy, so ENEA. And these are certified results. Basically, they came at our demonstration plant, and we have been testing the product for almost 1 year. And this for us is a sort of assertion of quality, because on this size there are not so many systems like this with high efficiency, like you can see there. I spent a few words to explain you, in case you don't know, but I'm sure you know, the basic operating principle of the system. The Thermex is a Fresnel technology concentrated solar. So we have linear mirrors with a small curvature. I can speak a lot about this curvature because that is the main aspect that differentiates our solution from others on the market, in the sense that we are very precise in focusing the light on the central collector. It is a normal pipe, a normal tube. Normal, not properly normal, because of course we have to limit the dissipation and so on. Anyway, in that pipe, in the collector, we can run the thermal oil, superheated water, and steam. As I was saying before, we have been testing the system up to 230 degrees. As I was saying, 230 degrees is not a physical limit for the system, of course. Concentrated solar has not a physical limit itself. Our system can operate at even larger, even higher temperature. We set this value as a limit because after that our efficiency curve drops. It drops because at higher temperature the losses coming from irradiation, more the convective losses, comes to be relevant on the total. That's why we used to say no more than 230, because it's normally an accepted value of losses at that temperature. some of our standpoints. Okay, the first one, we call it as flexibility. So with the same system, in fact, we had the aim of serve different conditions, serve different businesses, and serve different processes. And as far as we are experiencing on the market, there was a good choice in the sense that with few modification on the line and on the design parameters, we are quite able to satisfy the request that we faced. Another point is the efficiency. Efficiency, yes, as you maybe understood, is a term that I like very much. It's not more a single value, in my opinion, but it's a combination of what our system can achieve compared to the cost, okay? And so both these strength points came out from a detailed design on manufacturing technologies, on material, and the concept, okay? So our intellectual property regarding the object is related to the manufacture of the mirrors. Okay, convenience because it all starts with the sun, that's true, in the sense that with that system we can have a wide range of possible application, and our task is to have an example of all of these possible services, at least in Italy, by the end of the next year. So now we are, as I was saying, we are building the small power generation plant combined with an ORC cycle, because as I was saying, we work at medium temperature range. We have already demonstrated even ongoing plants on industrial process heat. We have even a solar cooling plant. We have no experience now on teleheating. Okay, some of you maybe, I don't know if in this area you have an experience of teleheating. In Italy is a method that is coming up with more and more evidence. And it's about the opportunity to serve a system of combined demanding thermal energy users with a network, okay? With a network that we can feed with renewable but even recovery heat energy. Someone of you could ask me, why do you need to operate at high temperature to serve a teleheating in a residential area? That's because it required a strong investment from the company, and even because now we feel more safe about the quality of the product. So I don't know if you manage the matters relating to the concentrated solar power, but the quality of the reflective surface for us is really delicate, in the sense that if we have many errors on that value of efficiency that we have been testing along wouldn't be true. So we need a particular system of manufacturing, and with this investment we are quite safe of the repetition of the process because it's completely automated, at least for that part. So it's what we call the way to the sun. Way to the sun is our roadmap that I hope will increase more and more. The project, as I was saying, started in 2012 in our office of Pontedera, near Pisa. As you can see, the first milestone of our road was the certification according to the EN 12975. Again, the first plant of 125 kilowatts as a solar cooling plant on a paper production site in Porcari, near Lucca, Italy. Again, the 2014 has been crucial for us because we have been visited by the man of INEA that gave us, many troubles, but even many satisfaction in the end. At November of 2014, we had the startup of 400 kilowatt solar cooling industrial plant. And across 2015, we have been able to deliver 3 more industrial plants with a total power of 600 kilowatts. For the next year, we have in charge to deliver 6 projects. And now that we have an integrated line, I hope we can do even better. And one of the motivation to come here is the possibility to extend our technology abroad, because the Italian market is not enough to sustain investment and not enough to sustain all the system we are creating around this project. Thanks for attention.